So before we start studying in detail about the advanced structural steel design, we should at least know the basics of the structural steel sections, basics of the structural steel properties, what exactly are the various type of profiles of the structural steel sections that are available in Australia and New Zealand. So first of all, we shall in this particular we can say section we shall start discussing about the basic details. So for starting, we can say that whenever we purchase the structural steels sections, the supplier always provide the quality certificate. So this is an excellent document by One Steel Manufacturing, and we shall be studying in detail about the various type of structural steel sections by this particular supplier. So first of all, as I said, that whenever we purchase the structural steel, the supplier always provides the quality certificate, and in this quality certificate, they say that, or we can say they certify that. Let us say the structural steel that is available that is in compliance to the AS/NZS 3679.1, and that is basically the code for the we can say structural steel sections, and or we can say materials. After that product, that is basically 410 UB 59.7. So UB is basically the universal beam. 410 that we and 59.7 that we shall study in detail, but we shall just to give you a brief idea, 59.7 is the unit weight of the section, that is in kg per running meter. After that, the chemical analysis is very important, that what are the basically the various percentage of the various chemicals that are available in that particular structural steel lot. So see, carbon, phosphorus, manganese, we can say, or silica, sulfur, nickel, chromium, molybdenum. So all these are, we can say, present in the structural steel that we purchase, or we can say that we use in our structures. After that, they do provide the mechanical testing also. So in this, we can say that the elongation percentage, that is in approximately 35%. And this elongation percentage is very important when we are dealing with the structures in New Zealand, where we are dealing with the we can say extreme earthquake or extreme seismic events. So it becomes very important to ensure that the structural steel that we are using is ductile. So that we shall study in detail also in the further lectures, but just to give you a brief idea that these are some of the chemical testing that always be there at the site whenever we are purchasing the structural steel sections. After that, when we are talking about the various types of, let us say, just to give you a brief introduction, the grade that are available. So if we are talking about the One Steel sections, they do provide 300 plus steel, and that is their basically copyright. So 300 plus steel means that approximately we can say the yield strength is in the range of 300 Newton per mm square. So this is basically the standard grade manufactured by One Steel for hot rolled structural steel sections in Australia. And we can say that in New Zealand, whenever we are talking, that basically the sections available are 300 plus S naught. So the basic difference between 300 plus and 300 plus S naught is basically the elongation parameters that are, we can say, much elongation is much more allowed for 300 plus S naught as compared to the 300 plus steel. So just to give you we can say, just a minute, we can just simply search the elongation allowed for, we can say, 300 plus S naught. So here we can say that if we're talking about the 300 plus S naught, so for 300 plus S naught, the elongation allowed is basically approximately 25%. But whereas whenever we're talking about the 300 plus, the elongation is allowed is 22%. Or we can say the higher the grade, if we're talking about the 350 grade, that is the yield stress is in the range of approximately 350 Newton per mm square. For that, the elongation we can say is in the range of 20%. So we have learned two concepts. First concept, whenever we are dealing with the high seismic earthquake zones, we have to ensure that the structural steel that we are using has to be much more ductile as compared to the non-seismic we can say the areas where earthquake is not governing. Second concept that we have learned is that whenever we are dealing with the yield stress, the more the yield stress, that is if we are going from 300 to 350, elongation becomes lesser. So we can say that for higher grade, the structural steel becomes brittle. For the steel that is in the range of 300 Newton per mm square, we are dealing with the much more better steel and in the form of ductility parameters. So that is the second concept. So we can proceed to the previous discussion. So we have learned that basically there are these two grades available, 300 plus and 300 plus S naught. After that, when we're talking about the we can say 300 plus and 300 plus S naught, obviously that is the we can say applicable for one steel, but we shall be discussing about the other vendors also. So just to in this lecture, we are dealing with the structural steel that has yield strength of approximately 300 Newton per mm square and approximately 350 Newton per mm square, depending on the thickness of the structural steel sections that we are using. Second, we can say important parameter that we do need to learn are that basically we do deal with the universal beams and universal columns. That is basically UB and UC. So in short form, we basically say it as UB and UC only. So yeah, the first number that is written is approximately 610 here. So it means that the steel section that we are dealing with has an approximate height, or we can say round off number, that is approximately 610, and the unit weight, that is the structural steel section unit weight or per 1 meter weight, that is approximately we can say 125. So whatever number is written here, so let us say number is written 101, it means that unit weight is approximately 101 kg per running meter and height is approximately 610 of the I section. So that is basically we can say a derivation of British sections. So in Britain, basically that was the first area where they had started these using these universal beams, or they are also known as in some countries as uniform beams or uniform columns, but in Australia the terminology is universal beams and universal columns. So that we have learned that the first let us say if you're talking about this particular steel section, so in this basically the height is approximately 360 and the unit weight is approximately 44.7 kg per running meter. Now what is the difference between universal beam and universal columns? The first difference that you can understand from this slide itself, that they are much more heavier, or in steel terminology we say that they are much more stocky. So they are very heavy also, but and the main purpose of fabricating these is that they are to be intended to be used as the used as the columns for the structural steel sections. So what is the terminology here? That is basically if you're talking about this particular section, the height of this section, that is basically 200 mm, and the width, that is also in the range of 200 mm if we're talking about the universal columns, and the weight, unit weight, that is approximately 46.2 kg per running meter. So that is the meaning of the name here. Similarly, if you're talking about 310 UC 96.8, it means that the height of this section is basically 310 and the unit weight is approximately 96.8 kg per running meter. So that was the basic definition of universal beams and universal columns. After that, as I said, that the basic each and every country has basically two different type of codes. One code basically deals with the design of the structural steel sections. For Australia, it is AS 4100. Second code basically deals with the material properties. So for Australia, it is AS 3679. Now we have one more code for materials, or we can say that is basically for the hot rolled the square hollow section, rectangular hollow section, that also we shall be discussing. But just for in this particular lecture, we shall be restricting our discussions onto AS 3679.1 because basically we are dealing with the 300 grade material here. After that, the other grades that are available, 300 plus L0, and we can say 350 and 350 L0. So broadly we can say that the common grade that is used That is basically the simple 300 grade that is used. After that, when we are talking about the length availability, so length is also a very important parameter, because uh, sometimes it do happens that logistics and transport from the fabrication workshop to the construction site, that itself is a very, we can say, difficult task, because considering the traffic restrictions in Australia. So we can have a section as long as we can transport from the fabrication workshop to the site. So one option is that we can, as a structural engineer, you can plan the splicing, or we can say design the splicing connections, so that we can fabricate or two different length, and then we can join them at the site via the, we can say, lap splicing, or we can say butt splicing, or there are different type of splicing connections that are available. So but the problem here is that, broadly, if you're talking about the dominant length that is used all across the world, that is basically 12 meter itself, because that is a very, we can say, transportable also, that can be transported easily at the site. However, in some areas where the traffic is like very, we can say, tight, or we can say the traffic is very dense, in those areas 12 meter may also becomes somewhat difficult. So we can have a length in the range of 9 meter also, but broadly the first preference is basically 12 meters itself. So after that, we have studied basic about the length that is available. Grade availability, as I said, that 300 grade is the one that is easily available in Australia, and the length that is in the basically range of 6 meters to maximum 30 meters. 30 meters, as per my experiences, we can say not transportable, that cannot be transported, and as per my experience, 12 meter is the one that is most commonly used. After that, different types of the, we can say, structural steel sections that are available. Now, if you're talking about the welded sections are the one that are basically mostly used in the bridges itself, where we just have to make a large eye girder, and on the top of that we can just plan our deck, and on the top of that we can just allow the traffic to run. So welded sections, these are like very large sections, these are very heavy sections, and they have to be, we can say, fabricated correctly by experienced fabricators itself. So that is the basic concept of the welded sections. And after that, universal beams, or just to give you a brief introduction, welded sections are the one that are uncommon in the sense that these are the sections that are easily available, that is 610, 310, 250, 200, 180. But for welded sections, wherever, as I said, that traffic is governing, or we can say we have to, the span is very large, or we can say the bridges, in bridges mostly welded section is used because the span is large, 30 meter, 35 meters, and on top of that the load is also very high, and their depth is in the range of, here you can say, 1200 mm, 1000 mm, 900 mm, 800 mm, 700 mm, and minimum up to 350 mm. So the difference in terminology is that they are known as WB and WC, that is welded beam and welded column. Second terminology we have already discussed, universal beams. They are also like simple eye sections, and the terminology is the same, that is the depth is the first number and the unit weight is the second number. After that, universal column. The difference between universal beam and universal column is that universal beams look something like this, but universal column has also a flange that is quite large, just to give the maximum, we can say, compression area. So that is basically definition of universal column. Taper flange beams are the one that have a flange something like this, that is wherever bending moment is high, we taper the section so that we can save the overall cost. How we can save the overall cost? By ensuring that the maximum depth is in the area where the maximum, where there is maximum bending moment, and minimum depth is in the area where there is minimum bending moment. After that, parallel flange channels, they are also known as PFC. So parallel flange channels are basically the C channels. So the purpose of C channel is to, we can say, predominantly being used in the secondary beams itself. So wherever we have a major span, or wherever we have to, we can say, ensure the major strength aspect strength ratios. So in those areas we have to proceed with the universal beams itself. But in the areas where we have to make secondary members, let us say the typical flooring is something like this. So this is the, I'm drawing a plan. So we can install, we can say, UC, four number of universal columns here. These can be UB, four number of universal beams. After that, for secondary beams, we can either use the PFCs. So that is the one of the option that we can use when we are, we can say, designing the structural steel. After that, universal bearing piles. These are piles that are used whenever in the shoring arrangement. That is, we have to support the soil. So these are basically they are also known as UBP. So they are used whenever we have to ensure that we have to dig the basement. Let us say this is the construction area. So what we do is that, and here we have to, there is the traffic also, and here also there is the traffic. So in this area, basically we have to make the, or we can say, install the UBPs, that is universal bearing piles. So that is one of the application. After that, equal angles and unequal angles. Unequal angles are not preferably used either in Australia or in other countries also. The first preference is to ensure that equal angles have to be used, because angles are primarily used as tension and compression members, or we can say in plan bracing. What exactly is meant by the plan bracing? Let us say we have to install a heavy equipment here, and we have to ensure that whatever lateral forces are coming via wind and seismic, they have to be directly transferred to the column. So what we do install a plan bracing here, something like this, so that whatever lateral loads are coming, they shall be directly transferred to the, we can say, universal columns. So considering the terminology here, that is 200 EA. EA means equal angles, and 200 means that this is also 200 mm and this is also 200 mm. So that is the basic definition of the equal angles. So after that, as I said that, this is the basic code, that is 3679.1 structural steel hot rolled bars and sections. After that, AS 1442, that is basically the code for carbon steel and carbon manganese steel. AS 1444 for wrought alloy steel standards, and AS 1447 for hot rolled spring steels. We are primarily, we shall be discussing about this particular code, that is 3679.1. After that, when we're talking about so this is like the classic example of the flat section that is available, and primarily flat is used, we can say that may be used as a grating for installation of the grating members, or we can say fabrication of the grating. But primarily when we are dealing with the heavy industrial structural steel sections, or we can say heavy industrial structural steel buildings, or we can say warehouses, we won't be using the we can say flat bars in that much, we can say, heavy application. So we shall be discussing primarily about the structural steel buildings itself. So after that, this is the code that we have discussed, and that is basically dealing with the two grades, that is 300 and 350. So this is basically the first application here, that is basically the equal angle. That is, this dimension and this dimension is same. This is basically unequal angles. So as we can see here that this dimension and this dimension is different. This here we can see this is basically the universal beam, that is UB. This is parallel flange channel, that is PFC. This is, we can say, square section, and this is solid circular section. And in primarily in building, as I said, we won't be using this much, this section and this section. We shall be only dealing about equal angle, universal beam, PFC and UC also. So we shall be discussing in detail about the UC in the further lectures. But this was just a brief introduction about the, we can say, the meaning of the various terms that we shall be discussing a lot in the further lectures. So in the next lecture, we shall be discussing about the meaning of this particular table here. Until then, if there are any issues or any questions in this particular lecture, we can discuss in the question and answer sections.